Hi everybody, this lesson is going to be a second part of chemical naming, and the type of chemical naming that we're going to do is how you name ionic compounds. And there's two types of ionic compound naming that we need to really discuss. I'm going to call the first one type 1, and in this type of naming we deal with a metal with a non-metal, but in this class of metal non-metal naming, it's only going to be for metals that are in group 1 or 2, and also for metals specifically silver, zinc, and aluminum. Now, in group 1, the metals always have a charge of positive 1. In group 2, metals always have a charge of positive 2, and specifically for silver, zinc, and aluminum, the charges are plus 1, plus 2, and plus 3. And so these are very common metals, and they always have these same charges. So since they never change, we always are going to use these as their charges, and as a result don't need to indicate them in any way. But we do have to remember what their charges are. And so let me give you a couple of examples. For example, say you have the formula CsBr. So Cs is cesium, and Br is bromine, but the bromine changes to a bromide. And when we name CsBr, we end up with cesium bromide, and that's all there is to it. Now, the second type of ionic compounds to name, we call those type 2, are ones which involve metals and non-metals. But the thing that's special about these is that the metals are not the metals listed above. And in that case, we have to use a Roman numeral to show charge. But charge is specifically of the metal. Okay, and so let's take a look at how we do this. Let's take a look at a name of FeCl3. Now, Fe is iron, and Cl is chlorine, but chlorine is going to change to chloride. Now what we need to do is we need to indicate, or first determine what kind of metal we have. Well, iron isn't group 1, or it's not group 2, or aluminum, zinc, or silver, or zinc, aluminum, or silver. And so we need to indicate the charge. Now, to figure out what the charge that we need to indicate or write, what we have to do is we have to look at this formula. Now, the charge of an ionic compound overall is always going to be 0. Okay. Now, with FeCl3, we can look at our periodic table and see that the charge of chlorine is -1. But there's 3 of them, and so that means our total negative charge is going to be -3. Now, if we want the overall charge to equal 0, that means then that when we combine the charges of both the metal and the non-metal, it's got to add up to 0. The negative charge is -3. So our positive charge has to be a positive 3. Now, the formula indicates that there's only one of them, and so that must mean that the iron has a charge of +3. And what we're going to do then is, in between the name of the metal and the non-metal, we're going to indicate with a Roman numeral its charge of Roman numeral 3. Okay. Another class of type 2 ions are when we have polyatomic ions. And polyatomic ions are basically named the same as type 1 or type 2, but we simply have ions to deal with. For example, and those ions are polyatomic in nature. For example, COCO3 Well, CO is cobalt. CO3 is carbonate. And cobalt is not group 1, group 2, zinc, aluminum, or silver. So we need a Roman numeral. Well, carbonate has a charge of -2, and this formula has one of them, so the total charge equals 0. Carbonate's -2. The cobalt has to be +2 in order to balance this formula out. And so in here I'm going to write a Roman numeral 2 to give me an overall correct name. We can go in the opposite direction. For example, if I give you ammonium nitrate, and in this case we have to figure out what we have here. Ammonium is NH4. It's got a 1+ charge. Nitrate is NO3 with a 1- charge. And so if you have a 1+ and a 1-, well, they're going to cancel each other out, and together we have ammonium and nitrate. And that's how you name ionic compounds of type 1, type 2, and polyatomic ions.